Lesson 8.8, Quadratic Equations, Difference of Squares. Our essential question is, how do you factor a difference of squares? We have one new vocabulary word, that's also difference of squares. If you think about what those words mean in math, difference is subtraction and squares means perfect squares. So the difference of squares could look something like this: a squared minus b squared, where both a and b are raised to the second power. If we factor a difference of squares, a squared means that we would have to start our binomials with a times a. And b squared, because it's a difference, it's being subtracted, one of our b's is positive and then the other one is negative. So factoring a squared minus b squared gives us the binomials a plus b and a minus b. I'll show you by foiling that that is correct. A times a is a squared. A times negative b can be written as negative ab. B times a can be written as positive ab. And positive b times negative b is negative b squared. So what you notice is that the two terms in the middle cancel each other out. So the result is a squared minus b squared. So a difference of squares is a special factoring pattern. And when you see a difference of squares, it should be pretty easy to factor, and it shouldn't require a lot of work. So here on our first slide, we have a couple of problems to foil, just to emphasize what your binomials look like. So I'm going to foil on this first one. X times x is x squared. X times positive 4 is positive 4x. Negative 4 times x is negative 4x. And negative 4 times positive 4 is negative 16. So, as you can see, again, the two terms in the middle cancel each other out, and we're left with a difference of squares. So difference, because it's a subtraction, and squares because 16 is a perfect square. 4 times 4, x squared is also a perfect square, x times x. One more problem that I'm going to foil, or on this one actually I'll use the distributive property. 3x times 3x is 9x squared. 3x times negative 2 is negative 6x. Positive 2 times 3x is positive 6x. Positive 2 times negative 2 is negative 4. The middle terms from the outside and inside products cancel out, and we get 9x squared minus 4. Again, it's a difference of squares. So 9x squared is 3x times 3x. Negative 4 is 2 times negative 2. So difference is the subtraction, and the 9x squared and 4 are perfect squares. All right, now we're ready to reverse the process. So starting with x squared minus 25, we can factor this into two binomials. This factoring pattern looks different from the ones that we've done previously, because the ones that we've worked on so far have either been trinomials or polynomials. So they have had 3 terms or 4 terms. A difference of squares has only 2 terms. So 2 terms, and it has subtraction. So only 2 terms here. And there has to be a subtraction sign in between them because it's a difference of squares. So anytime you're factoring and you see just 2 terms with subtraction in between, you should check to see if it's a difference of squares. So x squared is x times x. Negative 25 is positive 5 times negative 5. And if you foil to check, you will see that the middle term does cancel out. So if I foil this, I'd get x squared minus 5x plus 5x minus 25. And those middle terms cancel out, giving me x squared minus 25, what I was looking for. Next one, x squared, x times x, negative 16 is positive 4 times negative 4. If I FOIL to check, x squared minus 4x plus 4x minus 16. The middle terms cancel out, and you're left with x squared minus 16. Next one, 16x squared minus 81. Still two terms, still a difference with the subtraction in between. 16x squared is a perfect square for 4x times 4x. Negative 81 is positive 9 times negative 9. So that's it. I'm not going to check on this one because I think you've got the hang of it now. Our next problem, 4 and 36x squared, perfect squares again. 2 times 2 is 4. 36x squared would be positive 6x and negative 6x. Now this next one's a little bit trickier because we've got more than one variable. It's still a perfect square though. 9x squared y squared would be a perfect square for 3xy and 3xy. Remember, your binomials, they have to look exactly the same, except for one has a plus and one has a minus in order to get those middle terms to cancel out. So we can't have 9xy and then just 1xy. That wouldn't work. We wouldn't end up canceling out with our outside and inside products. So they have to look the same. They have to look the same except for one gets a plus, one gets a minus. And then 1 times 1 is 1. So 3xy plus 1 and 3xy minus 1. This next one is similar to that. 25 is a perfect square for 5, so they both start with 5. 49x to the 4th, y to the 4th is a perfect square for 7x squared, y squared. So one gets a plus, one gets a minus, and they both get 7x squared, y squared. And that is our last example. So those are the two trickiest ones. Remember, you can always FOIL to make sure that you're factoring correctly, because FOIL and factoring reverse each other, or the distributive property and factoring. So you should be able to write a summary now, answering the essential question. Make sure that you restate the essential question and write complete sentences. And then check with your teacher for your homework assignment.
Hey, are you done with it?